HyPR-Sim is an application consisting of several simulators. Among them, a demo on Kickland will run now. The rest of simulators such as Hydrate Free for gas hydrate simulation, Hypersizer, Bridgening and Wellbore Strengthening, Crystal Amaze, brine PVT and salt preparation at desired TCD and density, SimCloud, Glycol Simulator will be explained later in the next videos. As the name of the simulator suggests, the kickland is specifically designed to assist operation in case of well kicked. The two common methods, driller's method and wait method, are covered in kickland. Meanwhile, a new method called combined method is simulatable in the kickland. Further explanation will be given about combined method. Let's click on the project tab page and load one of the well where data has already been updated in the database. It's clear that well control calculation for both methods, drillers and wait, are simple and quite straightforward, and all operation team members working at the rig site are fully expertise in the well control calculation. But once the well has kicked due to the critical situations, our colleagues at the rig site may panic and subsequently the killing operation will not be properly managed. Personally, I've experienced a well kick during an operation and observed how team members reacted with uncertainty. This was the main reason to develop an application which can assist the operation in order to return the well under control, where all members feel diligent to complete the task with a better cooperation. At the beginning of each section, casing profile. BHA. Known pressure loss for any tools such as mud motor or measure while drilling tools must be entered manually, as frictional pressure loss may differ from the calculated pressure loss. This is due to the presence of flow restriction in this type of tools. Bypass. If any tools such as under-reamer or divert valve are placed in the BHA, it's necessary to key in the percent by volume of the flow pass to annuals prior reaching to the bit. Survey data. For new section service data can be entered as per plan and can be updated if there are any differences between the actual recorded data and the plan. Otherwise, survey data as per plan can be used. However, for further accuracy of the well killing process, survey data can be easily copied from an Excel file into the survey table. If well is drilled vertically, then the check box shown here is ticked. The next step which needs to be taken once shoe is drilled out are FIT and LOT. In the pump table, the flow rate will be updated based on the required flow rate that is supposed to be pumped in hole. Let's run pipe in hole. If the well has kick data should be recorded once the well is shut in, and the recorded data needs to be entered in kickland. Required data are kick vol, expected kick depth, shut-in drill pipe pressure, shut-in casing pressure, active mud density, difference in elevation between standpipe and choke line. Choke line data includes mud weight fluid which is placed in the choke line. It needs to enter the mud weight in case mud density in choke line is different than the density of active mud. Otherwise, this text box can be left empty, as the system will automatically consider active mud density as this default for choke line surface length, and choke inner diameter. And lastly, the desired overbalance pressure shall be written down. Mud properties of active mud needs to be entered in the mud properties table. Then click on mud balance tab shown here in order to calculate kill mud density required to kill the well. Once clicked, the data will be calculated. Data such as required kill mud weight at bit depth, required kill mud weight based on anticipated kick depth, kick volume interval length in feet or meter based on the selected units, kick interval in TVD, kick fluid SG. This part is calculated based on different recorded pressures between shut-in casing, drill pipe, and calculated kick interval in TVD. Kick placement, below or above bit depth. Additionally, required kill mud weight and hydrostatic pressure applied at the shoe depth will be calculated accordingly. Calculated data at shoe depth will appear in red color if the kill mud weight required at shoe depth exceeds LOT. This may indicate that the well will undergo loss and gain condition at the end of killing process. Loss at the shoe depth and kick at the anticipated kick depth. Let's change the LOT for further clarification. LOT pressure amends from 1000 to 500 psi, which is equal to the EMD at 13.053 ppg at the shoe depth. As the kill mud weight required is 13.258 ppg, there is a risk of shoe being fractured in the killing process. As shown, the font color turns red as shoe figures in static condition at the end of the killing process exceeds LOT. Okay, let's change LOT to its initial recorded data and proceed with the killing. Based on the calculated kick fluid density, the fluid type will be chosen automatically. If necessary, the user can change it. As previously mentioned, pressure loss for downhole tools needs to be entered in the BHA sheet. Here, it's required to write down mud weight and flow rate for the known pressure dropped in BHA. Well killing calculations can take place at any desired time sequence. The recommended time sequence is 60 seconds. However, to perform stimulation faster in this demo, the time sequence is considered at 300 seconds. In addition to the overbalanced pressure that here is considered at 200 psi, a safety pressure, margin pressure, can be applied. If frictional pressure loss during pumping mud in-hole exceeds the margin pressure, then the margin pressure automatically will be declined to 0. If calculated frictional pressure loss is lower than the margin pressure, then the variance will be applied as further back pressure to the choke. For instance, if frictional pressure loss is calculated at 30 psi and the margin pressure is entered at 50, then 20 psi as back pressure will be applied to the choke. For the first killing simulation, let's proceed with the driller's method. Some of the calculated parameters are ECD at shoe, kick depth and well TD, new placement of kick, applied pressure at shoe, bit depth and well TD, standpipe pressure known here as pressure in, required choke pressure known here as pressure out, kick volume expansion or compaction. There will be a reduction in hydrostatic pressure applied on kick fluid as kick rises to the surface. Hence, kick volume expansion will be calculated. No expansion is considered for kick fluid type if water flux. Black oil expands lower than volatile oil, and gas will fully expand due to its characteristics. As shown in the executive page, all data will be plotted. Now, let's run this simulation using weight and weight method. And now, the combined method. In this method, the well will be killed in multi-stages. In the first circulation, the kick fluid will be circulated out of the hole. In each of the next stages, the well will be killed partially based on available heavy mud at the surface pits. In each consequent stage, mud density and rheology reading of the mud that is being pumped in the hole needs to be updated. Once mud circulates in the hole, choke pressure will be recalculated accordingly. This multi-stages pumping fluid will be continued until the well is fully killed and choke back pressure becomes 0. As shown, the choke pressure has fallen to 0. And finally, let's simulate kick tolerance and find the maximum permitted kick volume that can be entered into the well bore. Firstly, let's reduce the LOT from 1000 psi to 862 psi. Then change kick volume from 10 barrel to 4 barrel and the shut-in drill pipe pressure to 679 psi in order to get a similar kick fluid density. Now, let's run this simulation. As shown, the displacement can be completed without facing any difficulties. Now, let's change the kick volume to 6 barrels and the shut-in drill pipe pressure to 667 psi and rerun this simulation. Now, let's change kick volume to 8 barrels and shut-in drill pipe pressure to 655 psi and rerun this simulation. Therefore, based on the recorded data, the maximum allowable kick tolerance is less than 8 and is about 6 barrels. Of course, kick tolerance can be increased by any reduction in the desired overbalance pressure. Let's amend the overbalance pressure to 150 psi and rerun the simulation with kick volume at 8 barrels and the shut-in drill pipe pressure at 655 psi and rerun the simulation as per new figures. Thank you for taking the time to watch this kickline simulation. Hope this video has manifested the proper usage and features of the app.